In this video, we're going to be looking at page 5 of this handout on trigonometric functions and graphing transformations. So we'll pick up where we left off. And we're on example 2. And in example 2, we're going to be doing two horizontal transformations. And we'll start by looking at the first two, A and B, which have to do with sine and cosine graphs. And again, I have the basic parent functions listed up here above so that we can use those for reference. So remember that when you have inside changes, which is what we have here, that these are horizontal. And when we have horizontal changes, what we're changing are the x values. And also remember, we reviewed this on Friday, that when you have the inside changes like this, that you have to factor it so that what I call the immediate coefficient of x is 1. So in this first one, I'm going to factor out a 2. So we get 2 times the quantity x, because 2 times x gives us 2x. And then we're trying to figure out what goes here, what goes right here. Well, we have to look at the pi that we have here. So, when you're factoring, like if I tell you to factor 2x plus 4, then usually what you do is you say, okay, I'm going to factor out that common factor of 2. And then because there are 2 terms here, I need 2 terms here. And this times this has to give me this, so I'm missing an x, and this times this has to give me 4, so 2 times 2 gives me 4. But also notice that what you're doing is you're really taking this term, the 2x, and you're dividing it by 2, so that gives you x, so that tells you that's what goes here. And then you're really dividing this 4 by 2, which gives you 2, so that tells you that that's what goes here. So we can think about this in the same way. I'm going to get rid of some of these extra marks here. That if I take this pi that's here and divide it by 2, that tells me what has to go here, pi over 2. Right? And then notice that if you distribute, 2 times x gives you 2x right here, and then 2 times pi over 2, these will divide out, gives you pi, which is what you need here. So that's kind of an easy way to figure those out. All right, so now that tells us the changes that we're going to have to make to our x values. And remember that the horizontal values always sort of do the opposite of what you think. So we're going to do the multiplication first, but the scale factor for this one is not 2. The scale factor is 1/2. So the first thing we'll do is multiply all of the x values by 1/2. So remember, these are the original x values on the parent function. That's where I'm getting those values. And then I'm going to, now it says plus pi over 2. So remember, I'm looking at this piece right here that says plus pi over 2. And because it's plus, remember with the inside, you always do the opposite. So we're going to subtract pi over 2. So when I do my multiplications, 1/2 times 0 is 0. 1/2 times pi over 2 is pi over 4. I'm going to let you do the arithmetic if you need to. 1/2 times pi is pi over 2. 1/2 times pi over 2, this should be 3 pi over 2 right here. 1/2 times 3 pi over 2 is 3 pi over 4. And 1/2 times 2 pi is pi. All right, then we're going to subtract pi over 2, so we get minus pi over 2. Pi over 4 minus pi over 2, so I'll go up here and do that one, but then I'm going to leave the arithmetic for you to do. Of course, you need a common denominator. So if we have pi over 4 minus pi over 2, common denominator is 4, so this becomes 2 pi over 4, so that becomes negative pi over 4. And like I said, for the rest, I'm going to let you do the arithmetic. Pi over 2 minus pi over 2 is 0. 3 pi over 4 minus pi over 2 is pi over 4. And pi minus pi over 2 is pi over 2. So those are our new x values, and because we're not doing any outside changes, there are no changes to the y values. So when we make this graph, I'm going to have to kind of squeeze it in here a little bit. I'm paying attention to the fact that I have some x values that are on the, that's what we're multiplying by, some x values that are on the negative side and some that are on the positive side. So I'm going to try to make this kind of symmetric. So we've got negative pi over 2 here, negative pi over 4, pi over 0, and then pi over 4 and pi over 2. And then we already said the y values don't change. We haven't done anything to those, so those stay 1 and negative 1. So if I want to kind of outline what I have now, here's my left edge, here's my right edge, here's my top, here's my bottom, and then the principal axis hasn't changed. So that's the box that I'm going to put my graph in. So using the sine graph as a model, right up here, again we know that the sine graph starts and ends, and in the middle is on the principal axis. So that means that's going to be here at the beginning, the middle, and the end. And then at the quarter point, it goes up. So here's sort of my quarter point, 1/4 of the way across this graph, so that's going to go up. And then at the 3/4 point, it goes down. So the 3/4 point, 3/4 of the way across is here, that's going to go down. And so then this is my graph. Okay. The period of this one has changed. So the period for this one is going to be this total distance from -pi/2 to pi/2. So if I do, let me do the calculation down here. If I do pi/2 minus -pi/2, which is the same as plus pi/2, that becomes 2pi/2, which is pi. So the total period for this one is pi. So notice that that has changed. And then the phase shift for this one is, we can read it right from here, is that it moves it left pi/2. And I also want you to notice, and this is not a coincidence, that this moving left pi/2 corresponds to this starting value for the period. Why? Because normally the starting value for the period, the x value, is 0. When I do the multiplication, it doesn't change that. It stays 0. And then when I subtract the pi/2 that comes from this, I get the -pi/2. For the cosine graph, excuse me, the first thing that I want to do is factor out the pi. So I get cosine of, factoring out the pi, and I'm left inside with x minus 3. So you can check that. X times pi gives me x pi, or yeah, pi x. X times -3 gives me -3 pi. And so that tells me that my scale factor is kind of weird, but the scale factor is not pi, but 1/pi. So the first thing I'm going to do is multiply all of these values by 1/pi. And then because it says -3, again, we do the opposite, so that's going to be +3. So when I multiply by pi, of course, 0 times 1, or by 1/pi, of course, that's 0. When I do pi/2 times 1/pi, again, I'll show you one, and then I'll let you do the arithmetic for the rest of them. So pi/2 times 1/pi, the pi's cancel out, and I'm just left with 1/2. Pi times 1/pi is 1. 3pi/2 times 1/pi is 3/2. 2pi times 1/pi is just 2. So you can see that we're, unlike over here where we still had the pi's left, we've sort of lost the pi's. All right, and then we're going to add 3. So 0 plus 3 is 3. 1/2 plus 3 is 3.5. 1 plus 3 is 4. This is 1.5 plus 3 is 4.5. And then 2 plus 3 is 5. So now we want to graph those, and notice that, again, the y values haven't changed. We haven't done anything vertical. But we have changed the x values. So our x values go from 3 to 5. And we have the 4 and the 3.5 and the 4.5. Make sure you have those labeled. And then the 1 and the -1, those are the y values. Again, those didn't change. So if you'd like to outline this, this is now sort of our left edge of the one period. This is our right edge. This is the top. This is the bottom. And the principal axis hasn't changed. So when I graph the cosine graph then, the cosine graph we know starts and ends up, and in the middle is down. So in this period, it's going to start up, end up, in the middle it's down, and then at the quarter point and the 3/4 point, it hits the principal axis. And here's our sketch of this one. So the period for this one, remember, period is the distance from the start to the end. So if I take 5 minus 3, we see that the period is 2. And then the phase shift on this one, with the -3, we know is right 3. And again, you can see that as our starting value for that period. And again, it's not a coincidence for this one because the x value started out at 0, the multiplication kept that at 0, and then the +3 shifted the starting value up to 3. So we'll stop there and we'll do the tangent as a separate video.